Hi, my name is Jessica Sachs. I'm really excited to be here and talk about testing with everybody. I have a pretty exciting, interesting background, I think, which makes me probably more exposed to test runners and quality control than most developers, having worked at Cypress and led the development of the Cypress component test runner, as well as starting out as a quality engineer. So I'm going to go ahead and present my screen, and we'll get into the talk. Cool, share screen. And we're going to do entire screen. Awesome possum. So I think this should work. Let me tab back. Yep, looks good. All right, so let's get into the anatomy of a test runner, what Vitest keeps getting right. So we'll talk a little bit about Vitest, and then we'll talk about general principles that test runners implement, like the parts of it. So this is me. As Jen said, I work at Hero Devs as of 3 weeks ago, and I led the development of the Cypress component test runner when I was there. And I recently, very, very recently, became a TC39 delegate. I'll be focusing on things like ESM mocking in the browser. Right now, there's no solution. It's Vitest. Vitest is the main way that you get that done. So you'll find me around the Vue, Vite, and Vitest ecosystems. I tend to be involved in things that relate to testing browser code. So Vitest's new reimagined browser mode, I get to pay attention and advise. So what's Vitest? Well, Vitest is a testing framework, and it was built by many of the Vue core team members and support testing Vite-based apps. So when it's now also the recommended browser test runner, test runner for Vue, because Vite is the recommended bundler. Previously in Vue projects, we had the Vue CLI. It was Webpack based, and it was the recommended bundler at the time for Vue 2. And around when Vue 3 was released, maybe a little bit after that, Evan came out with Vite. And Vite has gone so much further than just Vue. And when Vite was released, it also needed a test runner because it was so ESM heavy and it leveraged a lot of browser primitives. And as I mentioned earlier, there are no good browser primitives to do things like intercept a file or otherwise, Jest at the time had no support for ESM and modules. So Vite came along and it was really, really helpful and solved that problem, and Vitest enabled that kind of mocking. So cool. Vitest is agnostic. So even though it was created by Vue, Nuxt, and the Vite core team, it was initially architected with single file components in mind. And if you don't know what single file components are, they're basically files that don't end in JS or TS, or JSX or TSX. So you're thinking Svelte, you're thinking Vue. And this is important because it was one of the main pain points for Vue and Svelte developers when it came to using Jest. Jest required its own proprietary module transforms, and that broke fairly frequently, and it was a huge maintenance overhead. So, stepping back, so that's the basis of what Vite is, or Vitest is. It's a test runner made for testing Vite-based apps. And we're going to talk a little bit about what's inside of a test runner. So we're going to talk about the anatomy of a test runner, the concerns that a test runner typically has. So a test runner, quite plainly, it's a program, right? It's a program. Let's see line 2 on our Node API here. You might call a function. And it's responsible for executing tests against your source code. Tests could be defined as maybe the collection of an it function, right? Or a test function. And inside the body of the test, you want to know if the Lambda passes or fails, right? Did you have an exception? In this expect, did it throw an error? You don't want the whole process to exit generally, but you at least want to know if you pass or fail all of your assertions. And so at its base, a test runner is a program that executes what you define as tests against your source code, such that if your code doesn't do what you want it to do, it will then report any failures. This is called a reporter. Yeah? Cool. So the simplest test runner, if you were to write a test runner today, its job is to parse and load your specs code, a file, and any source code you import. Then you invoke each spec file to create what's called a test plan, right? All of those its, those describes that you might have, those test functions where you take a string first, and then you have the lambda, the test body second, those are used to create a test plan. So then it collects all of those. They're called runnables. We'll go over that in a second. It executes all of those runnables it collects, and then it executes them, right? Executes the lambda bodies. And then if you have expectations that pass or fail, the reporter will then start to aggregate them. Finally, the test runner generally exits with success code 1 or 0 so that you can fail CI properly. So that's the basic test runner. You could, and I've done this, just make functions like called it and describe, and in one single file, define your test runner as the most basic thing ever, and then write a try catch, console.error if you had an error, and then, exit the process if there was an issue. So you can write your own test runner in like under 100 lines. But there are a lot of features that tend to be involved in creating a test runner. The part that's most interesting to Vitest in particular, and this is what it does differently than prior test runners in the JavaScript ecosystem, is it is responsible for parsing and loading your specs code and any source code imported. So in Vite-based applications, sometimes you have specific module import identifiers, like it supports a question mark. All of this stuff, a lot of this stuff, is browser ESM compliant. However, implementing it in a different test runner would be onerous and expensive. So Vitest gets this right, as do more and more test runners and bundlers and such, like Storybook now is allowing you to switch between different module bundlers. Cypress component testing. Before Vitest existed, about a year before Vitest existed, I wrote Cypress component testing maybe a month after Vite was released. And for a long time, it was the only way to test Vite apps because it reused your Vite config, just like Vitest now does, which is really great, but Cypress was much slower. So awesome. So finally, here's a picture of what a reporter might look like. You've seen possibly other reporters. If you remember working in more legacy code bases, you probably have an XML file or an HTML file that would report out your results rather than just in the command line. Cool. So here's what I will do while we walk around the different responsibilities of our test runners. So we have things like the execution context. This is something like, will you be running your test runner inside of a browser, or will you be running your test runner inside of Node? These kinds of things. Runtime mocking and stubbing, when you're dealing with dates, when you're dealing with objects. How do you do like just.function, vi.function, spy on, those kinds of things? Test runners generally provide APIs for those. In older JavaScript runtimes, we had things like sign on. Nobody knows how to pronounce this, by the way. I've asked many people that should also know, and nobody's like sign on versus sign on. So runtime mocking and stubbing, when you need things to be fake in order to check if like a function has been called or not, a test runner generally provides those things for you. The reporter we talked about, how do you collect the results of your test? Some way to start it. You have your Node API or your CLI, right? So just as an executable, the test runner generally provides you that versus you just invoking a main file, right, that a test runner could provide. Spec file preparation, the part of the test runner that's responsible for glob matching, right, or doing things like convention, such as jests under test under folder. Network mocks, sometimes, not all the time, sometimes test runners provide you the ability to intercept requests. Cypress does this with sci.intercepts. Other times, the framework relies on other tools like mock service worker to enable you to do network mocking. Test run orchestration. This would be when you're collecting multiple spec files and then making sure you can do parallelization perhaps, or if you've ever seen the run and band option in Jest, that's how you turn off parallelization. And then runnables and the assertion library. Runnables would be your it, describe, context blocks, And assertions would be everything that comes after the expect function. So instead of, using conditional logic, which is, if you think of the execution of a spec file, if my HTML value doesn't contain the string such and such, I would like my test to fail. Assertion libraries give us pretty ways in order to describe that behavior versus conditionally failing, if you can imagine an if block or something like that. So a lot of these features come for free with the program that we would call a test runner. And it allows us to have a very ergonomic way of approaching quality, right? We're not writing a lot of code that looks kind of like source code. We're interacting with a DSL, right, domain-specific language, and a lot of utilities and conventions. So we have a nice, neat way to step through tests that looks almost the same from test file to test file, spec file to spec file. So in here, this is how I would describe a runnable. A runnable is the basic building block of any test suite or spec file. When you step through a spec file, when the test runner steps through a spec file, its job is to execute only the registration functions. These runnables are responsible for registering themselves on some sort of test plan, right? And it contains a description, right, which is the English string that would say, this should work, or this element should contain these accessibility tags. And then you would pass it the second argument, which is the function of how you make sure that it does the thing that you're trying to describe. You also have cleanup hooks, lifecycle hooks. They're either before a test or before a runnable, after the runnable for cleanup, before each runnable, right? If you have a suite of it blocks inside of the root of a file or inside of a describe block, this is how you define, like, please clean up the database, please clean up these network calls. And tests and suites are actually kind of the same as far as the test plan goes. Next, you have your assertion library. This is the other thing that you interact with the most. And assertion libraries have a few different flavors, actually. But we'll talk about matchers and retries to start. So matchers are the functions that you call after the expect function. So you would say, I expect this subject, and then you tell it what you want. So to contain, to match, to be visible. If you're using something like Playwright or Testing Library or Cypress, you get into domain-specific matchers that are used to dealing with DOM nodes as their subjects. To be called with, also domain-specific. It's used to deal with spies, right? How many times has this callback been invoked? Matchers are responsible for that. And sometimes matchers are separated out from the test runner. In Vitest's case, Vitest actually ships bindings that play nicely with either chai-style dots or jasmine-style camel case. And that was made that was a design decision made to allow for very easy migration between test frameworks and Vitest. It's a really good decision. I've done quite a few Vitest migrations. The other thing that's really important for browser-based testing is assertion retries. Assertion retries basically say that you can register an expect call, and it will retry that expect call over and over again up to a certain amount of times. Time, generally, like 5 seconds or 1 second. And it allows you to wait for things like animations to end, especially, or network calls to resolve. So to be visible or to exist are two matchers that want to retry getting, let's say, the HTML of an element over and over again. And eventually, hopefully, it changes off of the loading spinner, and onto the actual content you've been waiting for. It's a very, very cheap way to deal with the inherent asynchronicity of the browser updating. You don't have to think about it, and Testing Library bakes in assertion retries. Playwright bakes in assertion retries, as does Cypress. So many browser-based test runners have these kinds of things. I have a blog post. I don't blog very much. I have a blog post that talks about rolling your own retriability helper. So no matter what ecosystem you're inside of, you can quickly get this kind of a retry behavior. It's pretty cool. Let's see. So next we get our execution contexts. So these would be browser-based or node-based. Node-based, you deal with JS DOM or Happy DOM, which is what Vitest ships with, or most Jest frameworks use. And then browser-based, or Chromium, you would deal with something like Cypress component testing or Playwright component testing. Basically, it's where do you execute the test runner and the subject under test, the spec files that you're writing. Do you have litmus test? Do you have window available? Are you in a real browser? Those kinds of things. That's the execution context. Generally, I advise people to keep the execution context the same as where their source code is running. Next, we have runtime mocking and stepping. I went over this a little bit, but here are quite a few things that a test runner may provide. You have things like modules and objects, methods and date, async and set timeout. Things especially with date and async behavior, you want to simulate time and you want to have determinism. So things like math.random aren't great. You generally don't stub out math random, but date you definitely stub out. Time zones you definitely try to set, so you don't have any randomness in that side of things. Modules you set when you don't have control over something, like if you're writing a CLI tool and you need to be able to intercept the terminal output. Module mocking is really good for that. Let's see. We don't have a lot of time for all of the things, but here's the zoomed out version. I'm going to leave this up for a second so you can, Command-Shift-3 capture all of this. But we talked a little bit about the reporter, XML. There's a little bit of code coverage that we didn't talk about. I mark code coverage as part of the reporter, but it's also part of compilation technically. Spec file preparation we covered in the overview. And test run orchestration. Spec retries, actually, really quickly. Spec retries are the concept very similar to retriability within the expect block. Spec retries are this file fails. Let me try the whole file again. And that might be necessary depending on if there's any local state in that file. Like if you have global variables and such, and you have a flaky test, it's better to just try the whole thing over again. You can turn it off and you're like, I actually want to fix the flaky test. But if you're looking for a quick hack around your CI being flaky, sometimes retrying the whole file can at least give you some sort of relief without having to do all the work. So yeah. Cool. So why Vitest in particular? It's fast, it's very, very fast, and its watch mode also leverages Vite's HMR. I also like it, because it's the only thing that works for browser-based DSM. It tends to be ahead of the curve in that regard, by necessity. And it's maintainable because it reuses your bundler config. It works out of the box with your Vite-based app. Even if you're not using Vite-based tooling, I highly suggest libraries use it, Node libraries use it. There is also the built-in Node test runner. I haven't used it yet. I generally write a lot of browser code. I'm also excited for Vitest's browser mode, which allows you to swap between environments. So if you want to have half your code tested in Node and maybe the other half tested in a real browser, you can do that with Vitest. And so I like the idea of a test runner being responsible for executing my code, my isomorphic code in multiple environments. So I'm very comfortable with the decisions the Vitest team is making. Finally, you're future-proofed. Testing a Vite app using Mocha or Jest requires you to re-implement your build tooling in either Webpack, if you're using Mocha and trying to actually give a whole bundle to the browser, or Jest transformers, or if you've ever seen module name mapper, you still do have a huge problem with, like, if you're trying to import an SVG. That's something that in your source code you could just write import icon from my SVG. And in Vite that would work in production. But you would have to then, if you were testing some source code, if you're testing some source code that's supposed to parse that line, import my SVG, in Jest you would have to go and implement configuration to mock that out. So not only would it not be production-like, you might not even return an SVG, you could return a JSON object as far as the test runner is concerned. So it wouldn't be production-like, and also it's an extra step of configuration. And every time you try to do something a little more interesting that just works in prod, you would have to go back and in Jest or in Webpack, re-implement that transformer that's test only. And so with Vitest, you get that for free because it continues to reuse your bundler config. So every time you do something a little more exciting, if you're using like WASM or weird stuff like that, you don't have to think about it when it comes to testing the code you just wrote. And that's a huge productivity gain. So, yep, this is the production light bit. Yep. I'm so happy that Vitest exists, honestly. And whenever test does not equal production, you risk releasing bugs that are covered up by your test-only config. So if you were to mock out that WASM code and it was just to be a smoke test, it was just to be like some no-op code, your app would say, hey, everything's fine. You know, you executed the no-op WASM file. Looks good to me. But if you were to then deploy to production, it might not even compile. But you wouldn't know because your tests aren't actually testing the code that you're shipping. And that is dangerous depending on the kinds of applications you're building, and easily solvable by choosing a tool that matches the environment that you care about. So, yeah. Maintaining I'm going to keep harping on this. Maintaining two sources of truth for asset pipelines, module resolution, and your environment. So environment variables, another big thing that you have to keep syncing between test and production. And you don't if you use the existing tooling that you've already configured inside of your developer config, your build config. So, virtual file resolution, this is a Vite-specific thing. Not a Vitest thing necessarily, but if you use virtual file resolution, like if you're using a Tailwind plugin, or you're using Uno CSS, for example, or some generated routes from ViewRouter, those kinds of things. They're essentially incompatible unless you go into that module name mapper option and you re-implement stubs that aren't production-like. So, again, built by Vue, Nuxt, and ViteCore. And so single file components, all of those files that end in .vue, that end in .svelte, they're first-class citizens. It's not just easy to use with JSX and TSX by default. You also get, .astro files are easy to import. This is why it's important, I think, to switch away from tooling that assumes only JSX and TSX. So, it's fast. Vitest is fast, it's maintainable, it's future-proof, and it's built by a group of front-end framework authors, not just one framework, right? So I think it's more well-rounded and represents the overall future of where we see the web going. Yep, that's all I got. So thank you. I hope you enjoyed this. A version of this talk is available at my website, just.sh/vitestanatomy. And you can find me on the internet, any one of the socials, just.sh, like a shell script. Thanks.
Yay! We have a couple questions for you.
Okay.
Let's see. Are unit tests more important than end-to-end tests or vice versa?
There's no definitive answer there. It depends on your business, the needs, the risk that your company has. I think you need both for sure. It depends when you invest in doing each testing type. But the short answer is when it becomes important, you should do it. And you should try to get ahead of the curve, at least with regards to unit tests. Unit tests will bite you sooner if your code base is larger. End-to-end tests you can kind of plug in whenever, and it's not too bad.
Very cool. Thank you. All right. Can you elaborate on how Vitest leverages Vite's hot module replacement for watch mode and the benefits this integration provides?
Sure. So essentially, Vite itself does a lot of optimization for their HMR. And it's most visible, like physically visible, if you're in browser mode and you can just literally see it update. So if you're changing, this might be a little crazy for people who haven't seen my browser-based testing stuff, but if you open Vitest in browser mode and you're changing like CSS to make something display none versus display block, for example, you don't have to recompile an entire module graph. That can be slow depending on the test runner. If you've set up caching rules specific for that test runner, in Jest you might have to opt into like watching certain files. It's nice when the watching and refreshing, reloading happens like it does when you're developing locally. Like it feels exactly the same.
Cool. Thank you. Two more, see if we can get through them. What portion of Vitest Runner do you think could benefit the most from further improvements?
The browser mode, and they released a discussion about it Monday. Yeah, this Monday.
Oh, yay.
Yeah. I was asked about it last week. I gave some feedback, and they had an offsite. The Vitest team had an offsite, and this was one of the big items they came back with. It's pretty cool. It'll let me remove Cypress from like everything I do, which is I built the thing, so I love Cypress, but I also want something really fast that I can use.
Very cool. And last one of what specific optimizations in Vitest contribute to its high performance, especially in comparison to other test runners like Jest or Mocha?
That's kind of like saying, why is Vite faster than other bundlers? It's the same exact question. So all of the gains that Vitest has, like such as like when they switch to roll down or whenever Vite does core improvements, Vitest benefits from them immediately. So it's the same answer. So Jest and Mocha isn't bundling. Mocha requires you to make your own bundles. But Jest has its own bundler in it, and it's not, built on ES Build. It doesn't have it does now have first class support for ESM, but at the time, it didn't have that for like 2-3 years. So ESM first, I would say, is something that Vite wins at.
Very cool. Well, thank you so much for your time, Jessica. We greatly appreciate it.
Yeah. Bye.